So I'm Rohit Agarwal. I'm the founder of Portkey.ai, which is an LLMOps company. I'm not too much of a coffee aficionado, but I think I prefer my South Indian filter coffee. That's my drug, yes.
Welcome back, everyone. This is Demetrios, your host, and we are here for another MLOps community podcast. Today, we're talking with none other than my man, Rohit, who has helped me so much along the way, as you will hear throughout this episode. He's currently working on Portkey. Before that, he was doing stuff in the LLM space, in the DevOps space. You can hear when he talks how fundamentally different he looks at working with LLMs as a software engineer. He's coming with that background. He's coming with that, hey, things need to be production grade if we want to serve them to the public. And how can we get there with LLMs? How can we make sure that we think about all of the different error scenarios or the worst case scenarios, those edge cases, you could say. I had a blast talking with him. He gave me two ideas that I'm chewing on now, and I think it's fascinating. It's funny because he's like, you've probably thought about this, but I'm putting a name to it. One is the AI Gateway, and I'm excited to hear what everyone else thinks when it comes to the AI Gateway. It's almost like this gateway, for lack of a better word. I think they did a great job naming it, where everything goes through that, whether it is an LLM call or whether it's, basically all of your LLM calls are going through this gateway to make sure that it's being routed to the right model, but also that it's getting the right prompt. So he goes through the 4 pillars that an AI gateway should have. Took me a minute to wrap my mind around all 4 pillars, but I really like what he's thinking about when he thinks about the AI gateway. So let me know what you think about that. The other piece that I want to mention and call out, it was towards the end, he talks about forward compatibility and this idea that people are a little bit scared to work on something because they don't know if in a month you're going to get a new open source model that comes out that renders everything that you're working on obsolete, or potentially OpenAI is going to come out with a fine tuning and then, shoot, like I don't need to be working on fine tuning Llama anymore, whatever it may be. But that kind of FOMO of the future and what's going to happen can lead to analysis paralysis, and you get a little bit paralyzed because you don't know what's going to happen, and then you're not able to take advantage of what you have right now at your fingertips. So his idea of, hey, we need to make sure that when we're building our systems, we are thinking about the potential futures. And I really like how he talked about decoupling our code from these API calls and what actually gets out. And so this goes back to the AI Gateway. Let me know what you think. As always, love hearing from you. And if you would like to help us out, it would mean the world to me if you share this with just one friend and let them know that you think they would enjoy this episode. That's all for me. See you later. Mr. Rohit, good to have you here, man.
Same here, Demetrios. I think we've been chatting on and off for almost, 4 or 5 months. So you've sort of followed our entire journey. So it's been fun.
Yeah, and one thing about the chats that we have that I always appreciate from you is, you're quick to help anything that I need in the community. You're always giving me a hand, whether that was the first LLMs in production report that we did where I was fully blocked and I got on a call with you and you absolutely unblocked me. I cannot say how much of a heaven send you were, because you went through that data, man, and it was obvious that you've been playing around with data for ages. You were able to bucket everything, and a lot of the insights that I put in the report came from the Excel sheets that you shared with me. So I appreciate that a ton. And then also, just the stuff that you're working on is in the hot seat right now, right? Like where you sit in the stack, it's in this new piece of the AI world where I don't think we were necessarily dealing with it back in the day when it was the predictive ML. as some people like to call it, or traditional ML. And now with the LLMs, we do have this whole new area that you're exploring. And I love getting insights from you when we talk on how you're looking at this area. And so I think that's a good segue into what have you been working on for the past X amount of time? I know it's been like a year or a little under a year. How long have you been working on this?
Yes, I think I've been working on this almost 6 months now, but been in this space, the generative AI space, the last 3 years. So I think we started off building, so I was at Freshworks, we were building a customer support product, and we were trying to incorporate AI across multiple areas there. That's when I think I worked on GPT-2 a little bit with our data science and machine learning team, then saw the entire transition to the earliest the closed model of GPT-3, which was Da Vinci, and then saw the next 2 years building a AI writing assistant with peppertype.ai. And then in those 2 years, I think the maximum learning was that the technology is truly magical, which we're seeing right now. There are just so many use cases across different verticals that are possible. But then if you were really to launch a production grade tool using the APIs that OpenAI or Anthropic or others provided, then you needed this entire tooling layer in place. And I think that becomes extremely, extremely critical at the moment.
And what is the tooling layer? I mean, what are they? And what are you seeing in the space? And especially like where you're playing and you've created Portkey, and like, what does the landscape look like?
Absolutely. I think if I were to almost, and from the very beginning, we've looked at it as, let's draw parallels from the traditional engineering world. So you used to have servers, you used to have databases, and then on top of these servers, you would have some sort of a server management layer, a database management layer. On top of that, you had this entire DevOps layer. So to manage your entire DevOps, there were lots of tools in different brackets. And these kept on getting more and more detailed, more and more niche as developers went deeper into applications.
Oh, can I stop you right there? So you're saying like something like you would have the cloud, you have your AWS, but then you also have your Kubernetes that sits on top of it.
Exactly.
And then all of a sudden on top of Kubernetes, you have Ansible that is for networking, and you've got all this fun stuff that goes with Kubernetes.
Yes, exactly, right? And then you have, on top of Ansible, you had these other plugins, you had open source libraries. To just even do a blue-green deployment, companies would use something like Spinnaker. So there's a bunch of these tools that existed for you to just manage your existing systems, and then you would build your application on top of it. And I think the main thing that enabled was people could build complex applications. So think about it, right? The pieces of the puzzle probably existed even in 2011, 2012, or even before that. But then all of these complex SaaS applications coming out after that, because a strong foundational DevOps tooling layer sort of evolved.
Yeah.
You didn't need to spend as much time monitoring servers or managing servers. You could rely on, an AWS or a GCP to do that. And then when you really thought about saying, I need to scale my application, do I need to do it manually? Kubernetes came in and helped out. And then Kubernetes became a pain, and then you built Ansible on top. So it's basically standing on the shoulders of giants and then enabling these really complex use cases to be built on top of what essentially is still, at the very basic edge, it's still a compute unit. But then how do you exploit that compute unit became this entire SaaS wave, I would say.
Yeah. And so you're seeing that, like, you're drawing a parallel to right now, and the compute unit is no longer a cloud resource, it's a foundational model.
Exactly, yes. So you would almost imagine a compute. So in place, and this is very loosely drawn, I'm sure the purists will butcher me on this, but let's take a compute unit as a foundational model. You want a quick way to look up these outputs of this compute unit, which is an embedding, which is where you need a vector database. So those two become your two core components. You have a model, and these could be multiple types of models. And then you have a vector database. On top of this, you will need something to really manage the deployment, etc., of your own model if you're doing. Or if you're just using an OpenAI or an Anthropic, then you don't need it. You just need to use the APIs, right? So then there is this one single layer of management, deployment, tuning your own specific model, which is optional, obviously. Now, on top of this stack, which is almost readily available today to all developers, sits this new layer which is evolving, right? So in the traditional ML world, and I hate to call it traditional because it's probably just 3 years, 4 years old, but then existed the MLOps layer, which were all of these amazing companies like Wits and Biases and Arise and Mosaic, etc., Databricks. Now there's a new layer evolving for generative AI applications, which is more the, and I think the jury is still out on, is it LLM ops or FMOps? But yes, there is this entire layer that needs to evolve that enables companies to build beyond chat with your PDF kind of applications. So I think not dissing on chat with your PDF, but then there's so much more you can do with foundational models that hasn't been explored till now. So you have this entire ops layer that needs to come up.
Okay, so yes, exactly that. The idea of drawing the parallel between what we were doing in essentially the DevOps world, or going from cloud to Kubernetes to a much more sophisticated Kubernetes ecosystem. And then that allows people to not spend time fiddling with the resources and spend more time building the products that are bulletproof, and they're not going to go down every other day because of scaling issues or whatnot. This is exactly what you're saying. Right now, we've got GPT and we've got these wrappers that are coming out that you can have your chat with your data, which is a really cool hello world, but you're looking forward to where are we going from here? What's the next step that we can create much more complicated applications with this that we do not have to worry about, hey, is this going to go down? We have these production ready things, and there are still quite a lot of hangups when it comes to using ChatGPT at a high scale, right? Or even any of these models. And so if you're using open source, you have your own can of worms that you got to get into. And maybe we can go into that. Like, what are some of these hangups that you've seen? And then how do you feel like those are being combated now?
So if you look at it in the closed source models, if you're using OpenAI, the biggest challenge almost everybody faces is the error rates. In fact, in our benchmarks across, and we do about 3 million API requests a day, we're seeing about a 5% error rate on the OpenAI base API itself, which is crazy because 5 out of 100 requests are going to fail. And then you need to build the systems in place to be able for it to either retry or fall back. And then there's so many other options that you need to do. And it's madness, right? Which engineer in 2023 is expecting a 5% error rate? But that's fair. I mean, you're
5% is so much.
Yeah.
Oh my God. Yeah. 5 out of 100, man. That's outrageous.
Exactly. And I think people are now beginning to deploy tools to production, and then users come back and say, hey, it didn't work for me because 5 out of 100 users are having a bad experience every single time. It's just, it's insane. And if you look at the open source models, I think, and I've been to so many conferences these last 2 months, almost every enterprise is like, hey, scaling this is really hard. The compute resources it starts to utilize is just crazy. And unless you have very solid defined use cases and a consistent traffic pattern, it's very hard to handle the spikes and the troughs, right? I think it's almost akin to saying, let me host my own server farm in today's world without any tools available. And I think it's the exact same problems of, hey, I have spiky traffic, my model goes down, I don't think I'm getting the best performance, I don't think it's most efficient. It's all of those same problems, which I think nobody wants to deal with. So I think on both ends, at the very base level, just deploying a model reliably is a challenge. And then you go above a little bit more saying, okay, how am I supposed to cache this out? Because caching doesn't work the same way as it did in the older world. So I need to build a new method of caching, and that's where semantic caching came up. Or I have multiple models that I need to keep switching between. So how do I build a quick model router? And so, problems keep stacking up. And I think in my brief stint, almost in 5 months, it's been that once you solve a problem, the next one emerges and the next one emerges. So it's just a string of things that need to be sort of solved for you to build a solid production level application.
Yeah. Yeah, the bottlenecks are real and you're facing them. You're kind of forging this new path right now. And so I would love to hear, as you're going through these 3 million requests per day, or as you're working with customers, you spent a lot of time on the report with me, and we have a lot of use cases that we highlighted from the survey, but that was now, dare I say, 3 months ago, and potentially all that data is stale, considering how fast things move, right? But I would love to hear, what are you seeing in the wild as far as use cases go, as far as like what customers are doing, and how is the use case, as you're like breaking through these bottlenecks, how is the complexity of the apps that people are able to build evolving?
Right. I think, so I always look at it from two frames of mind, right? So you have the in-production applications. So people have experimented for a while. They've figured out the best paths. They figured out value. And then we're seeing stuff in production. And then there's still things that are in the experimentation phase. So let's probably talk about both a little bit, right? So in the production phases, I have seen 3 kinds of applications, and it's almost everything that I've seen fits into these 3 applications, right? One is you either have a summarization type application, which is, here's an ArcSIF PDF, give me a summary. Here's my financial report, give me a summary. Here's a YouTube video, give me a summary. So those are, I think, very base examples, but then going deeper into meeting summaries, convert the summary into an action item list for me. Can you also put it into my to-do list? So those are things that are becoming popular. So, summarization as a concept, really popular. The second one is this Q&A. And I think this is the most popular use case right now. So if you look at RAG is probably the defining production feature in almost every software application that exists today. So be it customer support, data inquiry, sales, internal IT use cases, almost every software that exists is just hustling to add RAG to their applications. And I think the key advantage people are seeing is now you can have, there was always this utopian world shown by chatbot companies earlier on saying that, can I just chat with all of this information, all of this knowledge I have stored? And for the first time, it's becoming possible, and to a very large extent, accurately possible. This is also the one use case that is not prone to hallucination too much, because if you give all of the context to a foundational model, they end up returning really great answers. So that's where I've seen people find a lot of ROI, and people are willing to pay for tools like this as well. So I think that's the Q&A use case, RAG use cases, probably the most popular right now. And the third kind of use cases, I almost categorize them as generative use cases, which is what the world even started with, right? So write me a blog post, brainstorm the pros and cons of this decision. Here's an email. Can you change the tone? Can you fix the grammar? I think one surprising thing, which I'd love to tell you, is that among all of the customers I talk to, fix my grammar or fix my tone seem to be the most useful use cases. And you'd imagine, hey, these are like super primary and Grammarly would do it, etc. But I think these 2 use cases see the highest usage amongst, if you launch 10 features and you have these two will probably get used the most, which is very interesting.
Yeah, and especially I think that works so nicely for people who English isn't their first language.
Yeah.
And so you can feel more confident in what you're doing and knowing that you've got the right tone. For me, it's horrible. I should probably use it because my tone is so bad all the time. But I just am informal, a step below informal always. You can never expect any formalities out of me. And if I do say anything formally, like, you should probably report it as somebody's hijacked my account, because it doesn't really work But I do see the value of that. The brainstorming, the talking with the different things. You did gloss over this, but it's the idea of agents and, hey, take the meeting notes and then convert it into a to-do list, put it onto my to-do list type thing. It feels like agents are still a little bit flaky. I know there's so much energy going into it. How have you been experiencing them? What have you been working with to try and like help that, or do you not even touch it? Like, explain to me your relation with agents.
Yeah, I think agents is another phenomenal tech. I wouldn't even call it tech, right? It's more a framework right now. But this framework is almost at the same accuracy level as GPT-3 was maybe in January 2021. So it's about 70% accurate because essentially you're propagating the error down every step. So the more steps and the more branches the agent takes, the more error rate it's prone to. So I think that's the reason we haven't seen agents in production almost at all. But it's one of those tech where a lot of experimentation is happening because everybody's expecting these individual pieces to come down to, the accuracy of the individual pieces to become really high. So if you're nearing, if all of the accuracy of the individual steps trends to be 99.9% and more, then you can have an agent successfully perform tasks. In areas where accuracy that much is not important, so, here's a code piece, write a unit test case, try it. If it fails, try again. Where you can have a recurring use case, we're starting to see agents come up. I think Code Interpreter is probably the best example of an agent. And OpenAI just releasing it out to the world gave people a lot of ideas on how you can really play with agents in production. So I think we're going to start to see a lot more of agents, a lot more of chains, a lot more of merging factual data APIs with probabilistic data nodes. And if you see, I think both Llama Index and LangChain, which are probably the primary orchestration libraries today, they are focusing on RAG in the direction of agents. So they're like, hey, today it's RAG, but very soon it's going to be agents. So every company is also building up to that. So it's like information retrieval, which is Q&A, and actions on top. So you have Q&A with actions. And then this, if you can do it multi-step, then it's an agent implementation in production. I think that will be the path for at least enterprises, companies that are really playing with this, with real-world users, and not just hobbyists who are experimenting with this tech today.
Yeah, I wonder where we are in the S-curve of, are agents going to be able to get to that point where we can reliably use them? And if so, when? Is it a few months out, or is it a few years out, or is it a decade out? That's the big question, because everything that you're saying is very true. If you're getting this 5%, if we go back to what you're getting on those 3 million API calls, and you're at 5%, as soon as you want to do 2-3 steps, that 5% is much higher than 5% error rate. And so you can't predictably rely on anything. And I don't know, do you see that 5% going to 0.01% anytime soon? That's the big question.
Yeah, I think it is going there. And with the launch of fine-tuning, and this is all very recent, right? Now it's almost a new architecture stack is evolving, which is, let's not use a generic model to do everything. Let's try to train very specific models on very specific tasks, which will then be high accuracy, low latency. And I think this is something that I'm very excited about. Will there be a worker bee, queen bee concept where you have a queen bee that orchestrates these smaller, extremely high accuracy models, which are cheaper to run, but then only do one task. And then if you have this orchestration worked out really well, then is when the agent comes out. So I think in the evolution of when an agent becomes useful, you need this base infra to be sorted out first.
Yeah. It's like I'm having deja vu, man. All of a sudden we're back to small models. What the hell happened? We went through the boom, and now, these large language models are cool, but small large language models are actually where it's at.
That's true. And If you think about it, these small language models might still not be small. They might
Yeah.
still be individual, 20 billion, 70 billion models, which are still fairly large. But because we've seen, 1 trillion parameter models, so a 70 billion model feels smaller. It's also much faster, cheaper to maintain. But then you
Yeah.
could probably have 10 of these models fine-tuned for really specific tasks, and they outperform the best model any day. In fact,
Yeah.
there are studies that came out that said, I think the number one use case for open source models today ends up being, uh, what's this? I mean, NL to SQL. And so many companies have now tried fine-tuning Llama 2 on NL to SQL, saying that, hey, it performs better than GPT-4 or any other NL to SQL model that's out there, which is fantastic because now individual companies can train their natural language queries to SQL on their own data on a really small, fast, open source model and get accuracy levels that are nearing that 98, 99% mark, which is when agents now become super useful, right? Because then you can say, here is my query, convert it to SQL reliably, get the data from my DB reliably, and then convert it to an insight that's useful for me. So I think all these steps, the individual accuracy levels, there are multiple, I think, research wings at play to improve the accuracy of each of the individual steps. I would say it's probably, I think, 6 months out, but given that everything moves so quickly, it might be sooner.
Oh, I like it. I like you giving a date. That's bold, man. That is a lot more than I would go off and say. But let's talk a little bit more about just a lay of the land as far as where you're sitting with Portkey and what you're doing,
Sure.
what you're seeing as far as the other tools around you and below you in the stack. I'm going back to that market map as the reference guide as what we created. And again, there's the foundational model, there's the vector database, there's the SDKs or the orchestration layer like the Llama Index or the LangChain or Haystack, all that fun stuff. And then there's the other piece where I think you play. And so give us the breakdown on that.
Yeah, absolutely. So I think we decided from our experience, the thing we're good at is when you want to take a app to production. So, done experimenting, taking it to production, and now you want to really find value once you go to production, is where you need an ops stack that helps you with 4 major things, right? And this is what we've come up with so far. I'm sure this changes every month. But right now we say first you need observability. You need visibility into how your system's really performing. So you need the classic logging, tracing, monitoring. And that's the observability stack. That's really important. The second piece is,
Are you also saying, though, observability of the data too, or are you not going that far? You're saying, hey, DevOps observability, like APM type thing.
even of the data. Yeah. So I think in this
Okay.
case, I think they become merged because you want to observe the latency, the cost, and the accuracy. So I think in previous DevOps worlds, latency and cost would almost imply accuracy because the API call is always truthy. So if it returns a 200 means it's a positive response. So in fact, fun story is sometime back we were discussing that maybe we need to invent a new HTTP code, which is a 224 or 225. I don't know what it is, but it's basically saying the API returned successfully, but the data may be false. So that's a new HTTP code that almost needs to exist now because APIs no longer are just success or error. It's everything in between.
Yes. Oh, interesting. But just going back to a little bit, it's not necessarily looking at the data streams or you're not observing the data flows. It's more just the data and how it's in there.
Yes.
On the prompt specifically?
That's trtrue. Yes.
Yeah.
Yes.
Okay.
So once the model's ready, so I think there'll be observability when you're deploying a model and you want to measure you want to observe a model. That's very different. This is more about observing all of the calls that you're making to the model and then making sure they're all, what's the cost, latency, and price of it. Yes.
Yeah.
Yeah, I think it's observability on a very different layer. It's not observability on the base foundational model itself.
Okay, cool.
So that's one. The second piece is you need a way to be able to connect to multiple of these models and try them out as simply as possible. So when a Mistral launches and you're doing Llama, you shouldn't have to completely rewrite your systems to see, okay, let me now try Mistral. But can you do a 5% A/B test with Mistral, test it out and see if it really works for your audience or not?
With the same prompts, or throwing in new prompts, or what does that look like?
Depends, right? With some of the cases, you could try the same prompt itself. In some cases, you have to change the format of the prompt. And some cases, you have to change the entire structure of the prompt as well. So you have to rewrite the prompt. So I think in all three cases, you need a system that allows you to do that transition from one to the other, test out, roll back, these all systems, right? So that's the second piece. I mean, we're calling it, that's the AI gateway, which enables you to do all of this.
Yeah. Hey everyone, my name is Aparna, founder of Arise, and the best way to stay up to date with MLOps is by subscribing to this podcast.
The third piece is the prompt management and experimentation. I don't know how far this goes, but today, almost every company that's interacting with LLMs, they have a prompt management stack. So how do you define your prompt library? How do you define experiments on them, etc.? And the last piece is security and compliance, which is how do you make sure none of your data is getting leaked? You have so much important data that's being put in the prompt or in the vector database. How is it not leaked? How do you stay compliant with your SOC 2, your GDPRs? So that entire stack, right? And this is what we're calling the complete full stack LLM ops. And that's the ecosystem that's evolving. And if I were to tell you where it's placed, you have foundational models. If you're doing open source, you have the deployment layers. Then you have the orchestration layer where you're writing code essentially on top of it. And this orchestration layer and the LLM ops layer now probably need to work together. So which is where you've seen a lot of, like LangChain is doing Langsmith, which is coherent, right? You have the orchestration layer and then you have the LLM ops layer. Similarly, I think a lot more needs to be done in the LLM ops layer, which is where Portkey plays.
Yeah. So if I'm understanding this correctly, and I like these 4 pillars that you're talking about, hey, we need observability. We need to understand, is it working? And if it is working, there's almost that element of evaluation that comes into it.
Yeah.
Of how well is it working? It's not just yes or no. There's a big gray area here. And so we have to figure out what that entails. That's the first pillar. The second pillar you mentioned, and you're going to have to remind me because I want to go through these. I remember the first and the last one, of course. That's how the mind works, I think. The last one, let me see if I got that right. But the last one is something along the lines of okay, now I don't even remember the last one.
Yeah, I think the last one was security and compliance.
There we go. That one, I knew it was important, especially because my friend Diego has been hitting me up with all of this fun stuff where they're talking about how, Panda packages or just regular packages that normal people will be using have been wrought with spyware or whatnot, and how the compliance is a big thing that gets overlooked. Yep. And the other piece to that is exactly what you're saying on the, you have all these GDPR compliance, whatever, but then you have, hey, if I'm going to be using one of these models, how do I make sure that it's not spitting out this data later on? And how do I make sure that the right people have access to the right data and not any more or any less? And it feels like with these large language models, it's a bit of a crapshoot right now. So that's a hard problem that I would love to dig into. But let me hear the two in the middle too. What were the other 2 pillars that you mentioned?
The other 2 is, so one is prompt management. So prompt management and experimentation. And the other is the AI gateway. So which is basically
the AI gateway,
multiplexing the multiple LLMs and making sure you're the best of, you can fork out to more LLMs than one, and then even keep trying out newer LLMs, coming back, etc.
And the AI gateway sounds like it could get really expensive really fast.
So the AI gateway is almost something we're saying becomes the central piece of any LLM product. So if you're building an application that uses LLMs, at some point in time, you will have to build an AI gateway, which is almost your gateway to the entire LLM world. And this can be a really fast proxy, which introduces really low latency, scales very well, but then allows you to load balance, set up fallbacks, do testing, connects to your monitoring stack, make sure there's a firewall attached to it. So, all of those things, again, traditionally going from, if I talk about traditional engineering, Nginx was almost a requirement when you went to production, or a Kong API gateway, or a Cloudflare. These were all things that were almost marked as checklist items, saying if you need to go to production, have a firewall in place, have an Nginx server in place. This is where an AI gateway will also come to place, where if you go to production with an AI model, have an AI gateway in place.
Yeah, that makes a ton of sense. So the AI gateway just points the different prompts or the different requests to the right models, and it allows you to quickly experiment, rapidly iterate, depending on whatever models come out, or the model of the month, basically. Or if you're having these failover, I can't remember how you put it, those requests, then you're getting a bit of redundancy and you're getting that backup to know that, all right, if I am getting the whatever timeout error from OpenAI, my service is not going to be affected because we can now hit Claude, or we can go and we can hit our Llama model that we have up and running.
Absolutely. Exactly. In fact, most people, what I've seen is they would have a load balancer set up between OpenAI and Azure OpenAI, because they're essentially the same model and you get more rate limits there then. Or you set up fallbacks from, say, a more costlier model to a cheaper model, whenever, for some reason, the costlier model is off. So that is where a lot of this comes into play. I think more than anything, we talked about the 5% error rate. We're now seeing that if you put a strong evaluation engine in place and set up these retries, load balancing, and fallbacks, with a solid AI gateway in place, you reduce that error rate almost to 0.02%, which is phenomenal, right? From 5% to 0.02%. And this is just data we were crunching, and I think we're going to release all of this data out in the public saying, and it's not just Portkey, you could do this yourself, but then you can reduce that 5% error rate significantly, which trends to the point you were making earlier, which is how do you make agents successful? Is when you have something like this in place, you have strong evaluations in place, and then you can start to trend that error rate near zero and make agents really, really successful.
Well, that was one of the questions that I wanted to get to. Was, you mentioned the worker bee and the queen bee type model. Is this a bit of foreshadowing for that? Do you feel like, hey, with the AI gateway, we're going to be able to first hit the big model and make sure that we know which one it is, and then that big model can use the AI gateway, it can leverage it and say, boom, now we know which model to go to next.
Exactly. Yes. And I think this will be on a triad of cost, accuracy, and latency. Because in a lot of use cases, you can't have a lot of latency as well. So you might want, hey, it's okay with a little less accuracy, but I want it to not cost me so much, or not be so, not take so much time. So it's going to be like a interesting mix of all of these three, which gives you the best output and the best user experience. It may not always be about accuracy.
Yeah. What are you optimizing for? And recognizing that you can have it fast, cheap, or easy, but you can't have all three.
Yeah. I mean, there's going to be some trade-off. Yes.
Yeah, there's those trade-offs. And so you know that, all right, well, if it's coming from this request, we're going to be optimizing for speed. If it's coming from this request, we're going to be optimizing for accuracy, et cetera, et cetera. So that makes complete sense. Let's dive into this security and compliance aspect. What were some of the hard problems that you solved with the security and compliance, and how did you go about that?
Sure. I wouldn't say we've solved a lot of problems, because there's just a ton of things to be done in security and compliance. And I think we might just end up partnering with some of these companies who are only focused on security compliance. We've done the basics. So, you need to have a PII anonymizer at your end. You need to make sure that none of the sensitive data crosses your boundary layer. So how do you do that? So we implemented a PII anonymization scheme, and that's extremely hard because you have to implement that in a compliant manner again. You can always call GPT-3 and ask it to anonymize, it'll do that. But then implementing the anonymizer in a compliant manner is the hard problem.
Yeah, that's not SOC 2.
Exactly.
GPT-3 is not SOC 2 compliant, right?
Exactly. So that's that. Then how do you solve issues around data residency? So if you need to be GDPR, but OpenAI is only in the US, then how do you really prepare for data residency? Which means, can you use OpenAI as a stateless server, which isn't storing any information? And the information is always stored in the NEU server. So the data does go out, but none of the sensitive data goes out. No PII ever goes out. It just processes a bunch of text, comes back, and then you're able to derive value from it at the other end. So I think those would be the two key pieces. The third being stopping DDoS attacks. So we've implemented some of Cloudflare solutions so that you don't get DDoSed. The problem with DDoS that we've heard with customers is that a lot of times their key gets compromised because of a GitHub repo or something. And then somebody just makes a lot of calls and, it's a direct cost problem to you because now you've probably spent $1,000 in a day, which you really didn't intend to because somebody got a hand of your key. So we launched something called virtual keys that allows you to store your OpenAI or Anthropic keys in a secret vault. We will give you these virtual keys, almost like virtual credit cards. Set up, spend limits on it, distribute it to developers. You could even do a hackathon, give out $10 credits to everybody.
Oh, nice.
And then the key management happens at the Portkey layer. And it's so much simpler because you can always decommission a key, you can remove a key, replace a key, rotation is easier because now we've sort of built an entire layer for it. So I think those are the three things that's something that we've done. But I can see a lot of applications around, and I'd love to talk to startups about how do you do access control and permissioning, especially with vector databases. I think today no vector database really looks at permissioning really closely. So data leakage is a sure possibility. I can essentially do a prompt engineering to get data from a vector database I wasn't supposed to retrieve. So how do you put those checks and balances in place? So my permissions, I don't exploit my permissions. So those are things that are becoming important. So, leakage is a problem. Prompt injections are a problem. So there's, I think, a bunch of things that companies, really interesting problems that companies are solving. We've probably done the basics, which absolutely need to be done. But we're looking to partner with some of these companies to do more.
Yeah, it's funny because it reminds me of a lot of the talk, and about a year and a half ago, the idea of the data mesh got really popular.
Yep.
And treating data as products, and that was a way to combat these data access problems. And you had the consumers and you had the producers, et cetera, et cetera. And I've heard horror stories of people joining an enterprise and not having the right access for data or just for systems, even 6 months after they've been working at the enterprise. And so taking all that into account and then recognizing now we're just going to kind of let that data loose with the LLM, it could be a recipe for disaster, right?
Exactly. Imagine you take your confidential internal data and fine-tune a model on it just to get great benchmark results. You do, but then I am probably a new joinee and I'm now able to access every information about the company because the model already has seen all that information. So that's just a nightmare. And you can't really, I haven't seen a good enough solution right now that can control the output of an LLM and say, hey, this is not data that you have access to, because there is no data control within an LLM.
Yeah. It's almost like you need to do the reinforcement learning with human feedback on top of the fine-tuned model.
Yeah.
That will just be your compliance layer. and
Yeah.
say, as an AI with your security credentials, you cannot, I cannot tell you that type of thing.
Exactly. And I don't think that's going to be an easy prompt to do because there's just hundreds of permissions that the AI has got to learn about.
Yeah, 100%, man. That is wild. That's really like, it makes you think twice about the use case that you're trying to solve for. And this one comes down to what is the worst that could happen, right?
Yeah.
Like, oh yeah, we've got this chat with our data and we think everything's fine, but what's the worst that can happen? If all this data is now free to anyone who is prompting the model,
Yeah.
is that maybe that's really bad or maybe it's not. So really thinking through that is a fascinating one. And then also the idea of like having these digital keys, I like that too, because it's like you're giving out Brex cards for the OpenAI keys almost.
Exactly. Yeah. Yep.
That's cool. So there is another thing that I wanted to touch on with you, which is the idea of forward compatibility. I know that you mentioned you were thinking a lot about this. I'm not super clear on what it is, so please explain it to me like I'm 5.
Absolutely. So I'm sure you've already thought about it in some form or fashion, but I think the term forward compatibility, let's look at it, right? So whenever you're designing any system, you always worry about backward compatibility. So anything I design now should be supported on every other system that my users are going to see it on, right? So it has to be compatible with browsers and machines and whatnot.
Yeah.
I think with AI, the pace at which it's moving, one constant fear I hear from enterprises is that, any investment we make might just get wasted 2 months from now. So should I be even fine-tuning my model now? Should I even build my own foundational model? So, and in that conundrum, almost there's inaction. So you can't take a decision, you can't move forward because you're like, hey, the dust hasn't settled and I can't move fast enough to really launch anything into production, which is where a lot of enterprises seem to be. They want to invest, they are investing, but then they're constantly caught on, we'll keep chasing a trend that changes too fast for our own likeliness.
Yeah.
And I think that's where the concept of forward compatibility comes in, where we're saying that you probably need to have a system in between your application and generative AI that allows you to keep up with the new models, the new databases, and the new frameworks that come into play. So how are you able to, so let's take this example, right? GPT launched 0613. They said, hey, this is the latest and greatest model we have. Go try it out. And that's it, right? But then how does an enterprise really try it out? They're not used to change management by just switching API endpoints. They have a testing procedure, they have user focus groups and whatnot, tons of things to do. So we're saying this is where probably a smart AI gateway can come into place, where now the enterprise goes and says, okay, GPT is launched 0613. We're seeing a good enough success rate with the previous version, but now we want to test this out. So they say, okay, let's route 5% of our traffic in a very dark mode. We're sampling some traffic and sending that out to GPT 613. The result that comes back is evaluated with stuff that is being shown to the user, which is from the older model. You do a quick evaluation over the course of a day, decide if this is worth shipping or not. So it's almost like a private benchmark that you're running in real time. Once you're satisfied, which is almost like a CI/CD test, you've ascertained that nothing has regressed, you can then say, okay, let's do a 5% rolling release to my users. So 5% of my users see the newer model, 95% see the older model. When you're happy, you can ramp it up to 100%. And now this entire orchestration can then be managed by an AI gateway. And the only way this is possible is if you decouple your AI gateway from your code. So you can continue to have LangChain, Llama Index, your own code that is making these calls to LLMs. But then you have something in between that lets you very quickly swap out and swap in components. So if you're using Llama 70B, you fine-tuned it. Can you also very quickly fine-tune a Mistral on the fly, test it out, launch it in a phased manner to your customers? And that's, I think, what we're talking about as forward compatibility.
Wow. Yes, that makes 100% sense. And the idea of that fear is real. I have heard people talk about it too. It's like, by the time I actually get the Mistral fine-tuned, is there not going to be a new model that is the flavor of the month? And I don't even want to mess around with Mistral? Or how do I know which, do I fine-tune Llama, or do I fine-tune Mistral? Do I fine-tune Falcon? And the ability to say, you know what, I'm going to try all of them and see if I can do it real quick, and then see which ones are giving me the best preliminary results. And then we double down on that one.
Yep.
And so you said something there that's also interesting that I would love for you to dive into more, which is decoupling the AI gateway from the code. Can you explain that more?
Yep. Sure. So I think the way to getting to this stage of forward compatibility would be, let's not hard code the OpenAI API call within my code. So within my code, I should decouple it to say, okay, I need to make an LLM call with this prompt ID, with this data that I have, and expect an answer. That's it. The AI gateway can then transform this prompt data and expected API call into the best possible model that's out there based on the rules I've defined. And then on the way back, again, transform the response into a consistent format that the code understands. So now my code never needs to change when I'm switching between models, when I'm switching between prompts. And that exists on a very thin, fast layer, which is the gateway.
I see. And it's almost like you can add in what we were talking about earlier on, what are you optimizing for? And so that the model or that call knows, okay, we're optimizing for speed, we're going to go for this smaller model. We're optimizing for cost, we're going to go for the open source model,
exactly,
et cetera, et cetera. And you don't have to put that specifically in the code. You just put pointers to the AI gateway, and the AI gateway knows what to do with it. So it's basically, the AI gateway is starting to make sense for me now. The AI gateway is like a catch-all for whatever you're doing. Nothing goes through your walled garden. Nothing can make it through to the LLM, whatever LLM it is, unless it goes through the AI gateway.
Yeah. Yep. Exactly.
And it makes sense why you would want to put the security and compliance layer there also.
Yes. True.
Because then it's like, hey, make sure that nothing ever hits the LLM that I don't want to.
Exactly.
Or, from once it hits the LLM, it's kind of too late. Then it goes straight to output. It doesn't go back through the AI gateway.
So it also goes back through the AI gateway. So you can ensure that no data leaves your walled garden that you didn't intend to leave. And whatever comes back from the AI can then be evaluated, tested on, checked for moderation, all of that, and then sent back. So it's basically just on both sides, you're making sure that we've picked the best prompt, the best model, and sent the request out. And then on the way back in, we've tested everything and made sure this is the best response that's possible, and then sent it back to the user. The magic is in how fast can you do it and how accurately can you do it. And that is where I think that's where we are most excited about, saying, how do you build the best AI gateway? And essentially, you can almost think of, how does this connect to a firewall that somebody else is building? Or how does this connect to, maybe we have our own observability there, yes, but you want to connect this to a Datadog. And hey, I want to do all of my monitoring in Datadog. Perfect. The gateway connects to Datadog as well. So that then evolves as the one product enterprises will use if they want to be confident about deploying LLMs in production.
Yes. All right. Fascinating. And then I guess the fun part there too is thinking about all of the possibilities that you now have if you're able to say, whenever I use the Mistral model, I have specific prompts, and the AI Gateway knows what prompts work best for Mistral. And so it takes that into account as it throws the data or the whatever my call is. And if I'm using 3.5, then cool, I have my specific prompts for that too. If I'm using 4, I have my specific prompts. If I'm using Claude, whatever it may be.
Yep.
And you don't really have to, in the code, specify any of that because the AI Gateway knows, all right, cool, we're routing this based on whatever conditions we need. We're routing it to Claude, so we know this is the prompt that we're going to use for this type of scenario.
Exactly. Yes.
Dude, I love it. I knew you were working on some cool shit. I didn't realize it was that cool. And I had seen the idea of this AI gateway because I think it came up in one of the threads in Slack, right? And that idea seemed like something that people were very much on board with. So that's awesome. Before we jump, man, I want to know, what was one of the hardest design decisions that you've had to make since creating Portkey?
Yeah. I would say it's something that we're still debating is going open source or not. It's not a design decision almost. I think it's more a company design decision. Do you want to do it open source or not? And I think we did a lot of thinking. We brainstormed with ChatGPT about it. Tell us the pros and cons of open sourcing this or not. I think we ended up deciding that, hey, the AI gateway is probably one of the pieces that we should open source, and we have gone ahead and open sourced. We've not really gone ahead and announced saying our AI gateway is open source, but Rubius is the AI gateway that we've opened up. That's got transforms to so many different AI models out there. It has caching, retries, fallbacks, all of these capabilities built in. And we'd love for the community to come in, look at it, build their own gateways following those principles or contribute back to it, etc. But that's been really hard we're not a non-profit organization. So how do you decide what to open source, what makes sense? And not just because the trend is to open source, we'll open source something, but what is meaningful enough that we open source into the world, and then what is meaningful enough that we keep it internal. So yeah, I don't know if that answers your question, but that was probably a very long and hard discussion internally.
Yeah, it's fascinating to me thinking about that because at the end of the day, a man's got to eat, and you want to make sure that if you're open sourcing something, it's providing value to people, but then you're not cannibalizing the business by open sourcing something, or you don't open source too much. And if someone's going to pay for your product, what is that extra value add that you're going to be offering to the different customers? So I feel you, man. I'm sure it's something that you still are thinking about, and you're trying to navigate your ways. And it doesn't help that everything is so new and everything is changing, and there's a new tool that's coming out in the stack every other day. And so it's like, where do we fit, where that identity crisis almost, and recognizing if you are an open source play or if you're a closed source play and how that looks.
Absolutely. Yep. That's true.
Well, Rohit, dude, thank you so much for coming on here and explaining all of this to me. I enjoy every time that we talk. You know this. I always appreciate all the help you've given me in the community and helping me understand things from a fundamentally different level. I also cannot thank you enough for the help you did on the report, and hopefully we're going to make another one of these with the evaluation report, and that's right up your alley. Some stuff that you're working on right now. For everybody out there that is listening, check out Portkey, show some love. And the open source project was called what again?
It's called Rubius. You can just search for Rubius. Yeah, Rubeus on GitHub.
Rubius, here we go. So go check that out, play with it, have some fun with it, and we'll talk to you later, my man.
Absolutely. Always a pleasure speaking with you, Dan.
Hey, I'm Vishnu. I'm a data scientist at First Hand, and I definitely think that you should subscribe to the MLOps Coffee Sessions podcast. It's the best podcast out there to stay on top of what MLOps actually is, to talk to the true thought leaders in the space. And oh, by the way, Demetrios is absolutely hilarious. What a weird guy. You should definitely subscribe to the podcast.